Alright, so this is Honors Geo, Chapter 3, Section 3, Proving Lines Parallel. In the previous section, we just talked about proving lines congruent with corresponding angles, alternate interior, alternate exterior, and then proving lines supplementary with the same side or consecutive interior. Now we're going to prove the converse. So previously we had alternate the corresponding angles theorem. This is the corresponding angles converse, which says if two lines are cut by a transversal, so the corresponding angles are congruent, then the lines are parallel. So we switched the hypothesis and the conclusion from the previous section. If two lines are cut by a transversal, so the corresponding angles are congruent, then the lines are parallel. So this asks if there's enough information that are going to conclude that M is parallel to N. You would say yes because, you would say no because corresponding angles are not the same. So this is 75 and this is 105. So since corresponding angles aren't the same, I don't have enough information to prove that these two guys are parallel. They want to know why postulate 15 and 16 are the converses of each other. Oh no, I was wrong on number one. They're not corresponding. So if you look at this, I was wrong on number one, so I'm going to do it right now. So if you look at it, this is 75. Its corresponding angle is not, it should be right here. So this is where the corresponding angle should be. I'm going to put X. But they give us 105. So this is a linear pair. So I would subtract 180 from 105. And that's going to give me my X, which is 75. So this is 75. And this is also 75. So the corresponding angles are congruent. Therefore, I can say that M is parallel to M. So corresponding angles are congruent. Therefore, I can say that M is parallel to N. Positive 15 and 16 are converses of each other because their hypothesis and conclusions have been switched. Alright, here's the theorems associated with parallel lines, their converse. So this one says alternate interior angle converse, which says that if we have two lines cut by a transversal, so that alternate interior angles are congruent, then the lines are parallel. Here's my transversal, here's my two lines. Alternate interior angles are congruent, therefore I can say line J is parallel to line K. Alternate exterior angles, if two lines are cut by a transversal so that alternate exterior angles are congruent, then the lines are parallel. Again, here's my transversal, here's my two lines, they are alternate interior angles, they are congruent. Therefore, I can say that line J is congruent to line K. Consecutive interior angles converse. If two lines are cut by a transversal, so that consecutive interior angles are supplementary, then the lines are parallel. Right? These guys are supplementary. Therefore, I can say J is parallel to line K. This asks, can I prove that the lines are parallel or why not? Here's my transversal. Here are my two lines, A and B. I have alternate exterior angles, and I'm told that they're equal by the symbol here. Therefore, by alternate exterior angles theorem, then I can say that the A is parallel to B. Here, I have this transversal, these two parallel lines, and I have these two guys that are congruent. Their corresponding angles. So by the corresponding angles postulate, I can say that A is congruent, parallel to B. Here, I have this transversal, these two lines, A and B. I'm told that 1 and 2 are supplementary. The only way that I can prove these parallel is by using alternate interior angles converse. However, the alternate interior angles converse says that the lines have to be congruent. Supplementary is not enough information to say that they're congruent. They could be. They could be 90-degree angles, even though they don't look like it. But I don't have enough information to say that they are. Therefore, I don't have enough information to say that they are parallel lines. Alright, so this is the proof of the alternate interior angles converse. It's a good proof. It's a 4-step proof. First line, 4 is congruent to 5. We can also use vertical angles theorem to say that. Congruence theorem. Never heard about that. Vertical angles theorem to say that 1 is congruent to 4. Then I can say in the third line that the transitive property says that 1 is congruent to 5. Then I can say by the corresponding angles converse that line J is parallel to line H. Then we have something here called a paragraph proof. And the paragraph proof is just a regular proof. However, it's just being written in paragraph form. You're writing sentences. Usually, each line of your 2-column proof can be converted into a sentence of your paragraph proof. That's what I do. I start off by writing a 2-column proof first, and I use it as my template to write my paragraph proof. So I'll say, oh, 1 is congruent to, or angle 4 is congruent to angle 5 because it's given to me. Therefore, by vertical angles theorem, 1 is congruent to 4. Hence, due to the transitive property of congruence, 1 is congruent to 5. Lastly, I can say that angle G is parallel to angle H because of the corresponding angles converse. Start off with your 2-column proof first, my recommendation, and then each line will become a sentence, and then you will have a paragraph. Okay, writing a paragraph proof. Again, this will tell you to look at it and to perform a proof this way, write words. However, I'm a big fan of just writing a 2-column first because it's less likely you'll make a mistake. You might think that you're writing it twice, but I think it's a great idea. Alright, so this one. Here's an example. They say that 1 is congruent to 3. They say that R is parallel to 5. So they want you to prove that P is parallel to Q. So what I would actually do is I would start a 2-column proof. And I would say, okay. I would say R is parallel to S. 1 is congruent to 3 because it's given to me. I can also say that 1 is congruent to 2 because of corresponding angles. If two lines are parallel, then corresponding angles are congruent. Third step, I can say, okay, 1 is congruent to 3, 2 is congruent to 1. I can say that 1, or 2 rather, is congruent to 3, transitive property of congruency, sorry. And I could say substitution, why not? And then number 4, I can say that line P is parallel to line Q because of alternate interior angles converse. Okay. Here's what's going on. So remember, parallel lines cut by a transversal. So if we were sorted to look at 1 and 2, in your mind, try to get rid of that P. That P doesn't exist right now. If you look at 1 and 2, then you can say that they're the same. This would be my transversal. We already told that they're parallel lines. So R and S are parallel. This is my transversal. So 1 is congruent to 2 because they're corresponding angles. We already told that 3 is congruent to 1. So 3 is congruent to 1, 2 is congruent to 1, then we can say that 3 is congruent to 2 using transitive property. With 3 and 2, R becomes my transversal and is cutting across P and Q. So if 3 is congruent to 2, and then they're positioning their alternating interior angles, so these alternating interior angles are congruent, and this line is cutting across these two guys, this is the transversal, then I can say that P is parallel to Q because of alternate interior angles converse. So then turn this into a paragraph. It's given that R is parallel to S and angle 1 is congruent to angle 3. Therefore, by corresponding angles theorem, angle 1 is congruent to angle 2. Consequently, angle 2 is congruent to angle 3 due to the transitive property of congruence or substitution. And lastly, because of the alternate interior angles converse, line P is parallel to line Q. Okay. And then we have our last theorem of the day. If two lines are parallel to the same line, then they are parallel to each other. So if line P is parallel to line Q, then line Q is parallel to line R, then line P is parallel to line R. Transitive property of parallel lines. Theorem. Okay, so that's this section. Hope you have a great rest of your day.